Okay. So the idea is it is polymorphism defines many forms, and it is a tenet of object-oriented programming. Can somebody tell me another tenet of object-oriented programming? Yes.
Abstraction.
Abstraction. Very good. Very good. Anyone else? One more. It starts with En.
Encapsulation.
Encapsulation. Very, very good. How about another one? One more for posterity. It starts with in. Hair.
Oh no.
In.
Inheritance.
Inheritance. Very good. So let's take a look at what we have here. We have polymorphism, and we have a common method right here for dress. Now, as you can see, hangout is a subclass for hangout and wedding. Our siblings. How many children does Get Ready, the class called Get Ready, have? Here's the Get Ready class right here. Okay? How many children does the Get Ready class have, if you can read this? Here's Get Ready, the parent class. Huh? How many children does Get Ready have? 2 children. And we see Get Ready has a method dress, Hangout has dress, and Wedding has dress. You would imagine they have different implementations, right? Because when you hang out with your buddies, you have one way of dressing, and when you go to a wedding, you have another way of dressing. So this is polymorphism. The fact that depending on the, I guess, the class that calls upon a method, the class determines the implementation. Okay, that is polymorphism because we do not dress the same at a wedding as we do to hang out. So that is polymorphism. All right, so let's say, for example, we have a variable called controls. It is a reference type of UI control super, which in the case of the program we've been working on is the super or parent class, and we have open and closed brackets. What does that mean? That means it's of type UI control super array, which means it has more than one thing to it. And we are creating controls with the new command, but we're doing it over 2 classes. We're creating 2 objects, new text box and new checkbox, because we're using UI control as a reference as an array. So controls actually has two new keywords. However, if we do this procedurally, it kind of is a new a very long if statement. Okay, we can say, because what we did here is we created a reference, we created another method called render. We created a method in the superclass called render, and we also have a render in the other 2 classes. So we add a render method to the superclass. That's this right here, if you can see that. Now, the reason why this is grayed out in IntelliJ is because it's kind of moot because it's an empty method, but we're just placing it here in the superclass so the subclasses can inherit it and then ultimately overwrite it. Okay, so we have the text box, and where is the render method? Well, it's not in there yet. We're going to put it in here. So we have checkbox, which extends UI super, public void render, and look at that, we're overriding it. That @ sign, and then the capital O overrides public void render. So in other words, it's inheriting render from the UI super, and then you're putting the @ sign and then override to let the compiler know that you're overriding the superclass's definition with your local implementation or definition of render. So instead of an empty method, it's saying rendering checkbox right here, because public class checkbox extends UI control super. We're doing the same thing here with text box. We're saying text box extends UI control super, and we are once again overriding the render method, and then we're just saying rendering text box. So this enables encapsulation in action. Each class has its own algorithm, or more aptly, implementation for rendering. And we are bundling the data and action in one single unit. We're bundling the data and action in one single unit. So instead of having 10 render methods, every class has its own render method. And this is polymorphism in action. So we're saying UI control super control, and then the name of the variable is controls, and we're doing new text box, new checkbox, and then we're saying for var control, and then we're running controls. Okay, we're iterating controls, and then we're saying, like, that could be an I, so it's like we're saying I.render. That should probably be I instead of control, but it is what it is. For control, and then it's going to go through the for loop controls. That's the name of the for loop. Okay, that is the name of the for loop. We're saying control.render, so it could be I and then saying I.render, but we're just using control as our reference character, and so it will go through the controls of each of these classes that have been created, and we can see it says rendering text box and rendering checkbox. Okay, now let's take a look at our class called animal. So these are, an animal is like any other class. We are going to divvy them up between fields and methods. Okay, now the methods that this animal does include make noise, eat, sleep, and roam. Isn't that typical? What do you think of an animal? Like when somebody says, if somebody describes somebody as highly animalistic, like somebody described, like what if I saw you down the hall one day, and a cop pulls me aside and says, "Hey, do you remember seeing this guy?" I go, "Yeah, yeah." He goes, "Well, how was he acting?" And I said, "He was acting highly animalistic." What would that mean? What does that mean?
Metaphor?
Huh?
Metaphor.
I didn't hear you.
Metaphor.
Oh, okay, yeah, but what am I telling him? How would he, if I said he was acting, or one of these guys are acting, or you, what if I said he was acting highly animalistic? What would that mean?
Sporadic.
how do you eat?
Actions.
How would you eat a steak?
Like,
With
does it mean
a-
like, does it mean like messy? Yeah, so they're a little just like,
Savage.
yeah, savage.
Savage, rough, that kind of a thing, right? So look at this. An animal, an animal's going to make noise, eat, sleep, and roam. You probably think of something wild, right? Well, look at this. Look at some of the children or subclasses of animal as you derive it. So first we go to canine, and then we go to dog and wolf. Wow. So wait a second. Dog and wolf are siblings, according to this chart. See that? Do you think a dog and wolf could be siblings? Could they survive with each other? Would you capture a wild wolf and just say, let him loose in your house and just say, hey, get along with Fido? No, I think Fido would be lunched, right? But yet, the wolf and dog would have, and because of that, the wolf and dog have distinct ways to make noise and eat. Like, how do dogs make noise? Right. Right. And how do what kind of noise does wolf make? Yeah. That's right. Okay, so wolf and dog do different things, have different implementations. How many children do you think? How many children do you think animal has? Well, how about this? How many grandchildren does the animal have? How many grandchildren? Huh? 5? Let's see, 1, 2, 3, 4, 5. It has 5 grandchildren. How many children? Yeah, very good. Very good. What are the most usable classes? What classes, if you're at a zoo and you wanted to represent exhibits, although let's presume dog is in there somehow too. All right, which classes do you think are workable, usable? Huh?
I'm sorry, I kind of lost.
Which classes do you think are the most usable? Hmm?
Canine and feline?
I can't hear you. What?
Canine and feline?
Canine and feline. Really? I mean, feline would have multiple. I mean, like, yeah, cat and lion. I don't think so. You would probably say you would get the most utility out of these and possibly this one, right?
Right.
Right. Now let's take a look at this. We know we can say animal, my hippo equals new hippo, because we can say that. But here's where it gets a little wild. Can we say animal, anim equals new animal? I mean, these two are the same type, but what would an animal object even look like? I mean, it's so broad, it's not even useful, right? I mean, like imagine, good God, imagine if you will, you were pulled over and a cop described you as a white animal. that be awful? But would it be technically correct? Yes, because we are actually animals. We're not plants. We're animals. But it doesn't really. If somebody described somebody as an animal, biologically that would be correct, but that would certainly have a weird connotation. It's like he was acting like an animal. Was he savage? Was he growling? Was he? And you're like, no. He was very polite and very articulate. Well, and you might be like, well, why did you describe it as an animal? And then maybe you'd be like, because he is an animal. Biologically, we're all animals, right? Would that be? Imagine if you had that conversation with somebody. You would probably not. Would you? You would probably presume he's not normal. Like he was, like never talked to any one single person before, or did not understand nuance or something like that. You don't go around describing people as animals. So what I'm saying is that you wouldn't want to necessarily be able to instantiate this class. Okay? Okay, and how some classes aren't meant to be instantiated. And so the idea is how can we prevent a class from being instantiated? You can write the word abstract before the class, and then that way subclasses can inherit from it, but you just can't instantiate the class. Going back to this, you'd probably want to inherit. Sorry, I was going to try to circle this, but anyways, you would want animal to, you'd want dog to inherit certain things from animal, especially these fields, because they all need pictures and they all have to have some sort of a food and hunger and all that. But it's so broad, you wouldn't want to inherit this. So the difference is a method that you, or a class that you do not want to inherit, you put abstract. Excuse me, classes that you don't want to instantiate, you actually put abstract in front of the class. Classes that you do want to instantiate, those are called concrete, but you don't have to put concrete. There's no, I've never seen concrete as a key word. So, abstract or concrete? Come on, what do you guys think? Are you sure? You wouldn't want to instantiate this. Right? So is that abstract or concrete? Abstract. Feline, abstract or concrete? Abstract. Good. Hippo. No, you'd want to. That's concrete. You'd want to instantiate it because that is not like a category. That's like an actual type of animal that you'd visit at the zoo or something. Canine. Abstract. Yeah, because you can divvy that up into two completely different things. Dog and wolf. Okay? Abstract or concrete?
Abstract.
Concrete. Because you would want to. I mean, people want to adopt a cat all the time. Tiger. Concrete. Lion. Okay, good. Okay. All right, so you do concrete, abstract here. Let's look about wine. So, wine, the term wine at a restaurant, abstract or concrete? Good, good. Red, just red.
Abstract.
Good, good. Cabernet.
West country.
Huh? I'm not even sure.
I don't know about concrete.
Yeah, I'm not really sure. I maybe concrete. Yeah, Pinot Noir. I would probably say concrete.
The Cabernet would probably be abstract.
Okay, because
It'd
there's.
have to be like Cabernet Sauvignon, like different.
Oh yeah, yeah. Because there's so many different Cabernets, cabs as they call them, I guess. Okay, so here we are with UI control. Okay, and the UI control is too vague to be abstract. Excuse me, is too vague, too abstract to be useful. Okay, so we want to utilize the abstract keyword right here. This is before, and this is after, just to let you know where to position and place the abstract keyword. You go public, and then abstract class UI control super. And again, complete UI control super class. We have public abstract class UI control super. Interestingly enough, uh, methods also can be abstract. Okay. Methods, as I said, can be abstract. So when you have an abstract method, okay, it prevents other classes from extending. You know, so as I said, it prevents other classes from extending. So if you go ahead, oh, I apologize. Now we're on the final keyword. Sorry about that. So the final keyword, that's another keyword. The final keyword prevents classes from being extended. Okay. And like I said, we don't want the subclasses to accidentally change the behavior. So we have final class extends this. Okay, so in other words, checkbox cannot be extended. Okay. And you can also apply the final keyword to method too. Okay. So with the final keyword applied to a method, it prevents it from being overridden by another class. So we have two new keywords that seemingly are similar to each other, and the final method also has similarities with the private keyword too. Okay. Okay, let's talk about deep inheritance hierarchies. The idea of inheritance is that we can reuse code and achieve polymorphic behavior. That's the main idea. But the idea here is we have textbox inheriting from UI control super, okay, but it's suggesting that we don't go beyond textbox, so we can extend textbox extends UI control, but then you can have another class that extends textbox, which essentially chains up to UI control. And then you can have all these chains that go almost infinite. And the idea is please do not create deep inheritance hierarchies. So in other words, don't go past a certain point. Example where deep inheritance is bad. Let's say you have an app that has both instructors and students. So we can abstract the instructors so that we have a subclass for regular instructor and another subclass for premium instructor. Maybe the regular instructor teaches the level 1 and 200 classes, and the premium instructor teaches the level 400 classes. Then add the student right here, okay? And now we have instructor and student. Now the instructor has 2 children, and student is standing by itself, but we can actually abstract user and then instructor and student. We can abstract user from instructor and student, and then from user we can that's an extension of entity, and entity now has 2 kids, and entity has 2 grandkids, and entity itself has 2 great grandkids. And the problem is you are now introducing multiple classes that are tightly coupled. They are tightly coupled, and let me give you an example of what I mean by coupling. All right, let me turn this off. Let me turn it back on. Okay, so do you see anything wrong with this right here? Look at this class A. So we're establishing class A, and there's one data field, we'll call it int A. There's another data field, we'll call it string name. And then we're saying void calc, and we're going to do return A times A plus 2. Now because, well, anyways, we have this. Now, this isn't one class. This is another class, the main class. All we're doing is we're calling this class. We're saying my A, var my A equals new A, and then my A dot A equals 2, and then we're printing out my calc. Pretty simple, right? Now, would you call these tightly coupled? Now, are these coupled? What do you think? Are they coupled? Okay. You say you have a doubt that they are. So let's take a look at it. This is A, the same program, the same little program in IntelliJ. We have class A, int A, string name. I don't really use string, I don't really use name, but I say public void calc, system out print A times A plus 2. Okay? Let's take a look at the main class. All right, public static void main, this should be var my A equals new A, my A dot A equals 2, my A dot calc, right here. Okay, should work out. Let's run it. But I don't just want to run it. I want to bring it into sight right here. Okay, here we go, finally. Okay, so let's run it. And the answer is 6. Because A times A plus 2. Okay? Because my A dot A equals 2. Makes sense, right? But we all agreed they're not really coupled, right? What if I did this? what if I did, I'm going to say calc is going to take, let's say calc takes another, let's do string name. Okay, and let's do this. See that? See that squiggly line? What's the problem? What's the problem? It's missing, now I'm missing a parameter. So suddenly, guess what? They are tightly coupled. Or at least they're coupled a little bit. Okay? So what it means is that one relies upon the other. Okay? And the issue with this is there's so many subclasses and, parents of subclasses that if you change something in student, that might influence the user, which might influence something that you might inherit from entity. So you have to worry about deep inheritance, and you want to avoid it as much as possible. Honestly, a better scheme is to have entity, course, you can have user as maybe a data field, and for instructor, you don't need two subclasses. You can have a Boolean of, is premium yes or no, and if he is premium, you can pay him an advanced salary or something. And here's something awful. Here we have multiple inheritances, multiple parents. So we have say hello A, say hello B, and then look at this. C is adopting from both A and B. Okay, now if A has their implementation of methods of the say hello method, and B has its implementation of say hello method, which version does C take? B or A? So for this reason, Java will not allow you to inherit from two people at the same time. So how would you even do that? You would say something like what? You'd say, let's see, you would create inherited, you would have class A, class B inherit from class A, okay? And then you would have two extends keywords. That's what you'd have to do to inherit from two classes, and it won't let you do that. It is forbidden, syntactically forbidden. Okay. So, anyways, it is 2:36. I'll let everyone get started on their assignment. Let me bring it up. All right, here I published it, so go ahead, work on it, and then probably about 3 hours I'll publish the answer, and then you can just go ahead and if you have to look at it, and then just make sure you submit it by tonight, midnight.